Hi, my name is Katie Smith, and I'm a third-year neurobiology, physiology, and behavior major. I've been studying greater sage-grouse in the Patricelli lab for the last 3 years, and I'm doing my undergraduate honors thesis on the Trivers-Willard hypothesis. And this hypothesis is essentially the study of if females favor sons or daughters. So, like I said, the Trivers-Willard hypothesis states that in lek breeding species, maternal condition will predict her preference for either male or female offspring. So why does this occur? In order to understand why, I'm going to go into a bit of a background and explain what lek breeding is, what role maternal condition plays, and how this all affects offspring sex. So polygyny is a type of mating system in which females typically mate once and males will mate with multiple females. But because there's this difference in how often males and females mate, males have to compete for females. And this can play out in a few different ways. Males can fight for females, like these elephant seals are. Males can attract females, like the beautiful peacock, or males can defend their females from other rival males. But in all three of these scenarios, condition is really important. So if you think about the elephant seal, they're really big and strong, and they have to be that way. They have to be in great condition in order to win a fight and win over females. Peafowl have to be in incredible condition in order to win over females. You have to grow this great plumage if you're a peacock. And male gorillas have to be really strong and fend off rival males to protect their group of females. So in polygyny, there's this really strong sexually selective pressure put on males to be in good condition. Lek breeding polygyny is the most extreme version of polygyny, if you will. And therefore, we see even stronger sexually selective pressures put on males to be in good condition. So in lek breeding, males will gather on a breeding ground called the lek, and they'll do this display for females. And this courtship display is typically a well-rehearsed, very elaborate dance that is done for the females. On the lek, females have complete authority over reproductive decisions. They get to decide who they want to mate with, and males will mate with any female that wants to mate with them. Because males are gathered in such close proximity, it's really easy for females to tell which male is of the highest condition and who she wants to mate with. So what ends up happening is that most females end up mating with these top few males, and those top few males are going to have paternity in up to hundreds of broods, but every other male will maybe go their entire life without ever mating. It's only these top few males that are reproductively successful in lek breeding populations. So there's this enormous variability in male mating success. And therefore, we can see how absolutely essential male condition is. If you're going to be one of those top few males to mate, you have to be in great condition. So this is really described greatly on this graph here. So we have on the y-axis reproductive success and on the x-axis condition. So we can see here a high quality male has really high reproductive success. But like I stated, low quality males will probably never mate in their life. On the other hand, a high quality female and a low quality female have roughly the same reproductive success. A female's condition does not really affect her ability to mate. However, a high quality female might just lay a few more eggs than a low quality female, and that's where we see this difference. But when it comes down to it, male's condition is very much so affects his reproductive success, but that's not really the case with females. So like I said, in lek polygyny, male condition is essential for reproductive success. In each of these species, this bird of paradise, the peacock, and the greater sage-grouse, these males, if they want to be successful, they have to be in great condition. And this is typically why in lek breeding species, we see these really extravagant and amazing morphological characteristics. So building on this, it's also known that maternal condition affects offspring condition, and this can happen in a few different ways. So as we all know, inherited genes, males and females both contribute their genes to their offspring. But maternal condition has a bigger role in offspring condition, and this is because in lek breeding, males have zero role in parenting. It's all females. After mating happens on the lek, that's the end of the relationship between males and females, and females will go off to raise the brood by herself. So a female's ability to raise her offspring affects the offspring condition, and that can be dependent on female condition. So this developmental environment provided by the mom affects the condition of the offspring, and that's how females play a role in offspring condition more so than the males. So we can see that if a female is in really great condition, like this female here, it is also likely that her offspring will be in great condition. So not only is male condition essential for his reproductive success, but male condition is also dependent on maternal condition. So these three species that I mentioned before, in order for males to be successful, it's likely that their moms were also in great condition. So just to summarize what we've discussed about lek breeding, only these top few males will mate, but these top few males will have paternity in lots of broods. Every female will mate, but they're physiologically constrained to one brood per season. So this means that if a reproducing female will have offspring that will be in good condition, it's evolutionary advantageous for that female to invest in male offspring, because if those males are successful, they'll have really, really high fecundity. However, if a reproducing female will have offspring in poor condition, she should definitely invest in female offspring, because those offspring will mate no matter what. So we can see here that the direction of bias in offspring sex is very dependent on maternal condition. And this is what the Trivers-Willard hypothesis states. It just means that a female will invest differentially in male and female offspring depending on her own condition. So this study here was done by PFAL, and it looks at how maternal condition here on the x-axis is related to offspring sex ratio. And this is measured by proportion of males. So higher up means a higher proportion of male offspring. So you can see a pretty strong linear consistent relationship between maternal condition and proportion of males. So you can see here, the red line is this 50-50 line. This would be equally investing in male and female offspring. When you lie above this line, that's when you're investing more in males, and below the line is investing more in females. And you can see that typically above the line, that's when you see females in good condition. So now that we've established a bit of a background on what the Trivers-Willard hypothesis is, I'd like to dive into my thesis that studies the Trivers-Willard hypothesis in greater sage-grouse, this bird. So to start, I'd like to discuss noise pollution. So noise and sound is an essential part of greater sage-grouse courtship, but therefore they're really susceptible to noise pollution. And because anthropogenic noise is becoming more and more prevalent in the ecosystem, I think that it's extremely important to understand the broader implications that our actions have, like noise pollution, on sage-grouse populations. So to discuss the theoretical framework of my thesis, just to quickly go over this, I'm interested in anthropogenic disturbances, namely noise pollution, how that affects maternal condition, behavior, and physiology, and in turn, how this affects her investment in her offspring and brood characteristics. And this right here is the Trivers-Willard hypothesis, how maternal condition affects brood characteristics, especially her offspring sex ratio, and how she's investing differentially in male and female offspring. Now, if we step back a bit and we think about noise pollution and other anthropogenic disturbances, these happen at the population level, meaning that every female is being affected by them. So if every female is having depressed condition because of anthropogenic disturbances, that's going to adjust brood characteristics and possibly brood sex ratios across entire populations. And therefore, this will skew population demographics. If population demographics are skewed, this will affect conservation efforts and how we're addressing species, and also that species population success, how they're ultimately turning out. So now I'll just dive right into my project and break down each aspect of the framework and discuss what project I'm doing. So my first project is looking at anthropogenic noise and how that affects maternal characteristics. So I'm looking at noise pollution, and US Geological Survey has used soundscape ecology to measure decibel, the noise level at each of female's nest site where she's laying her nest. They've also taken data on the females. So they've taken morphometric data, meaning body measurements like weight, wing chord, culmen length, tarsus length, things like that. And they've also taken blood from the brachial vein, which can be assayed for corticosterone. And corticosterone is the hormone associated with stress. So we have these two metrics of female condition, her body condition measured by morphometrics and her endocrinological stress. So through these measurements, we can look at how the decibel level at a female's nest site is affecting her body condition and her physiology. The next project I'm doing is looking at how maternal characteristics affect her fertility and offspring biases. So I'll be comparing those metrics that I just discussed before, the morphometrics, the body measurements, and her corticosterone concentration. So how a female's body condition is affecting her maternal investment in brood characteristics. And there's a few different ways of measuring this. So the first thing I'm looking at is fertility. How many offspring is she having, and how many of those eggs are fertile? I'm also looking at offspring sex biases, namely sex ratio. So of those offspring, how many are male and how many are female? And finally, offspring sex allocation, more resource allocation. So if a female is favoring one sex or another, maybe a female is making bigger male eggs that have a bigger yolk and a higher calcium carbonate concentration in the eggshells. So the eggshells are a lot thicker and stronger. So these are all ways that I'm measuring maternal investment in brood characteristics: fertility, offspring sex ratio, and offspring sex allocation. And finally, I want to predict how these population demographics are affecting conservation efforts. And this is really the importance of my research. So a really great way to explain why this is important and why my project is important is using the kakapo as an example. So the kakapo is a lek-breeding parrot native to New Zealand, and they were critically endangered. So conservationists took a ton of kakapos into captivity in order to try to restore their populations. While in captivity, the kakapos were provided with really high quality diets that were likely not provided in nature. And so all of the captive females were really bulked up and in great condition, which you would think would increase their viability and their fecundity. However, because females were all in fantastic condition, they all had really male biased offspring sex ratios. And when this generation reached sexual maturity, the tertiary sex ratio of that population was very heavily male skewed. And if you have a male skewed population, that's horrible for population restoration. So the kakapo example is precisely why a lack of understanding of the Trivers-Willard hypothesis can be really detrimental to the application of conservation efforts. So why am I using greater sage-grouse? I'd like to discuss the importance of the species that I'm using. So the first thing is that greater sage-grouse are a very common model organism used for studies on lek-breeding birds. So the more we know about them, the more efficient our studies can be in the future. Moreover, greater sage-grouse are an umbrella species, meaning that in protecting greater sage-grouse, we're also protecting sage-grouse communities as a whole and sagebrush communities, the entire sagebrush ecosystem. And finally, they're species of conservation concern, so will also contribute to implementing productive conservation efforts if we understand more about this species. And finally, we're able to predict population demographics. So that's essentially my thesis and what I'm studying during my undergraduate career. And just to summarize quickly, I'm going to go over my theoretical framework again, but now with the little icons, so it makes it maybe easier to understand and remember what I discussed. So I'm looking at how noise pollution affects a female's condition measured through body morphometrics and her corticosterone concentration. And I'm looking at how this will affect her brood characteristics, her fertility, her offspring sex ratio, and her offspring sex allocation. And finally, the importance of my projects. So what I just discussed, those are the projects that I'm studying, the Trivers-Willard hypothesis. And the importance of my research is that from this, we're able to predict population demographics, which will help us implement better conservation efforts and predict population success. So that's what I'm studying during my undergrad. Thank you for watching. Before we go, I'd like to acknowledge some people who've been really helpful in this. Eric and Gail, who have both been amazing advisors for me and really supportive. USGS, especially Pete and Stephen, they have provided a ton of data for me and really made me able to do this. The Patricelli Lab and all the grad students for being amazing and supportive and making my undergraduate career fantastic. Dave, who has been great and has been training me on how to dissect sage-grouse eggs. Kate Laskowski, who's always been supportive to me. Dr. Euler McCants, who's doing the genetic work for me. And finally, Tomas, who's been interning for me and helping me dissect some of these eggs. Now, one last thing, I am offline right now. During the undergrad research conference, I will be doing field work and won't have service. So I'm not live and I'm not online to answer your guys' questions, but if you have any, I'm absolutely happy to answer them. Please email me and I will get back to you as soon as I get service. So thank you so much for watching.